Good evening. Hi, baby doll. Little Peeper, good evening. Tyler, good evening. I saw Glazer in there. Good evening, everybody. Thanks for being here. As always, it's nice to have company while I do this. So we are in, what week are we in? We're in week 13. So, hello, Damien. Nice to see you here, or have you here. Okay, so next week is Thanksgiving week, but just you probably have already gotten reminders if you're taking other classes, but Butte College does not take the week off. We only take Thanksgiving Day, Thursday, and the Friday off, so for our class that means we need to proceed as normal. So I made the individual project 3 due at the end of this week so that you could clear it out if you had things that you want to focus on next week that aren't school. Hopefully that helps. But we will proceed with our normal routine otherwise next week. So on Tuesday night next week, I will be here doing a broadcast. There's already videos up there if you want to get ahead for some reason, although probably you're working on the project. The remaining weeks all have supplemental videos, so they all have lecture about the content we're doing. They all have walkthroughs of the labs. Heads up, spoilers everywhere. But just so you know, Butte College does basically normal school on Thanksgiving week. So for us, that means the routine won't change. So sorry about that. But for us, we have a pretty content dense class. So we don't want to miss any time that we have anyway, because you'd be getting robbed of things that there's a good chance you're going to want to know moving on from here. Okay, so we are in week 13. Good evening, Robbie. So we're in week 13, and the topic is recursion. And what I want to show you or tell you before we start is that recursion is a way of solving problems. It's a way of thinking about and solving problems. We don't need it until the 4th project. But the way I've designed the labs to work is that we usually, I give you a little bit of extra time at the back end of a project cycle, but we're already starting the new content. So this week's lab is some material that we're going to apply on the last project. I'm going to come back to it actually, and I think you can, let me make sure that's true, you can see the notes, you can. So if you look at the notes on the side, I'm going to start and spend most of my time with you tonight getting us prepared, unless a few of you have already submitted the project, but getting us prepared to complete the project. So the project uses a doubly linked list, and at first glance you might feel a little bit intimidated by the project setup. So I'm just going to start right from scratch. It's the first thing we're going to do is I'm going to look at how do I work on the project. So we've already started a little bit. I'm going to open that in a different tab actually. So that's part 1 rather, is that's most of our time together. Part 2, I'm going to just give some introductory comments about recursive algorithms. And then I'm going to have to rely on you to go watch the content that I've already created so that we can spend most of our time on the project stuff. So that's the plan. So I have the project open, and we'll just start. I'm just going to pretend like I just saw it for the first time. So source files have documentation. That means all of them. So every file that I have that has programming in it, I should put my name, the date, and the description of the thing at the top of it. That's my minimum requirements for documentation, but all source files need that. So that's easily handled, but it is 25 points. Neat and consistent formatting and naming. Hopefully you're at the stage where you don't think about that much anymore, but that's a requirement. And then we have the driver component, the part that actually loads the file and processes it. We started talking about that during week 11, so if you didn't see that video, that's where to go look at that, although I'm going to reuse some of that code tonight. And then the big one is the doubly linked list and making sure that it has all of the functionality that it needs and that it works so that the input files produce the desired output. So we're going to work on at least some of that so you can see how I would go about solving this problem. Okay, so doubly linked list, very important. We started talking about that last week. The driver, very important, because if the driver is not functioning, then it's impossible to test the doubly linked list the way the project's set up. So we got to get all the parts working, of course. Okay, I don't know what my screenshots do. Oh, my screenshots just show you your program's supposed to print stuff out, but we'll look at that together right now. So if I click to the repo, it's intimidating looking at first, but we're going to walk through it. So let me get my REPL open. I started a project 3 REPL last week. So last week we did some testing of the basic functionality of a doubly linked list. I found a bug, so we fixed that. But this test code needs to be set aside because the project is not a test. It's actually going to process a file, and it's going to take the file, map those to commands, and then produce some output. So I'm going to actually move this stuff. In fact, I'm going to cut it, and I'm going to put it in a text file off to the side. So one thing to note here, by the way, the reason why I put .txt, can you see? You can. Okay. So one reason I put .txt as the file name is because the way REPL works, when I click run, it looks for all the CPP files and tries to compile them. So if you put something in .txt, REPL won't try to compile it. So that's kind of what I want here, is for REPL to ignore that file. And then I'm going to do the actual project in here. I'm going to need my doubly linked list, the file we started last week. I'm going to need IO stream because the program is supposed to produce outputs. I'm going to need file stream because I have to read a file. And I want to say that's probably everything. I think that's probably everything, so hopefully that covers me. So I've got my setup. This is my driver. If you don't know the term driver, the driver is the part of the program that has main in it. In C++, the main function is the entry point of a program. So when you compile and run a C++ program, it starts at main. That drives the rest of the program. So when I say driver, when we say driver in our business, we mean the file that has main in it. Okay, so pardon me, I got an itch on my eye. Okay, so this is my setup for my driver. I know that I'm going to have to use this. I know I'm going to need to read a file. I know I'm going to have to produce some outputs. That should be everything that I need for the driver part. We already know from last week, since we started talking about it, that we have some extra functionality we need to implement to make this work. And I'll show you where I got that from. But I left some dangly pieces here. Back, pop back. In fact, that was the only dangles that I left as we began to convert this to a doubly linked list. Okay, so here we go. Let's go back to the project repo. Okay, so what you need to do is you need to, at least the way I would do it, is look at this file that says required operations. This is a list of all the commands that may appear in a file that your program encounters and has to cause those to do something with your doubly linked list. So a hash, a pound sign at the beginning of any line should be ignored as a comment. Then we need be able to handle a create. Notice, by the way, it says dynamic list, so that's important. We need to be able to clear the list of contents. We need to delete the instance, the dynamic instance, and set its pointer to null. So this is supposed to be a dynamic list, which means pointer to a list, and new and delete. So no static list, dynamic list, dynamic list, dynamic list, null pointer. So we need a pointer to a list, and then we're going to use new and delete to do things dynamically. We want an insert function. We don't have that function yet, but we're going to want that. We want a add number to the front. That's push front. We have that one. So maybe what we should do is take these commands and put them in our driver and begin mapping code to them. And if I want the compiler to not grouse at me, I can comment, oops, I can comment the whole thing out. So my program has to respond to all of these commands and cause these things to happen. That's the idea. What does the project say about the... Yep, so the driver has to accept a file name on the command line, so we're going to have to fix that as well. So hopefully everyone's still following what it is that I'm up to here. So we need int argc char *rb. You've seen that before. I'm not going to talk through it, but I am going to code mine up real quick. So if you're watching later and you've forgotten, we did this like lab 6 or so, then you can go back and review that stuff. You've done this before. You've done all these things before, except for the doubly linked list stuff, but you've done the singly linked list stuff, so you have a sense of where that part of the program's going. So I need I'm just going to code this up real quick. So argc equals 2, then I'm good to go. That's just making sure we get an argument, right? We've done this before. Okay, what else do we need? So we need to try to open the file, right? So I'm just going to go ahead and start coding that. And I'm going to do, I'm going to put file stream. I'll space it out so you can see it better, but I'm not going to go slow on this part because you've seen this before. I'll say failed to open. You've seen all that stuff before. All I've done so far is I've made sure that I have something on the command line, and then I try to open it as a file, and if I can't get it open as a file, then I print an error message, and that's the end of the program. If I don't get an argument, then I print out a usage message, and that's the end of the program. You've done that before. Okay, so I'm going to do this slightly different than we've done before because I want you to learn how to design software using functions. So if the file is open, it's up to you. Maybe I won't because it might be too much for you to take in. But you've seen all this code before. Line, in, next line. Reading the file. So it's going to spill off the screen pretty soon. I've done nothing that you haven't done here before on multiple occasions now. So hopefully everything that you see here you have some memory of having done it. But I'm going to go fast through the stuff that we already know how to do and less fast through the stuff that we don't know how to do. So we're going to do if I guess it is caps lock. nothing. So hopefully everyone see where I got that. If you look down here, here it is. So if the first character is a pound sign, don't do anything. So I literally wrote an if statement that just won't do anything, and it's fine. And I'm just going to go down through these commands and see what's required and see if I have the functionality to map to it. Okay, so that's part one, else if. Don't use if here. That would just be bad programming. If the first character is not a pound sign, then else if we test for the next thing. The next thing we're looking for is a capital C. And that means create dynamic list instance. So I'm going to do this slightly wrong, and then we'll see if you can figure out what I did wrong and how to fix it. But the basic idea is I need a dynamic list. It's going to be of integers. I know that from the project. I think. Well, we can look at the input file, can't we? And it says numbers. Let's look at sample input. So these look like integers. So I'm going to use integers just in case some smarty pants puts a negative number in there. We'll be able to support that. So pointer to it, and we'll call it list equals new BL list. Should do it. So that's what I'm supposed to do on create, is create a dynamic list instance. It's right here. So that's fine. Now it's not perfect. There's a problem, but I want to see if you can pick off the problem when I go to the next thing. But I certainly have the functionality to create a dynamic instance of a W-link list. If we look at my header file, here it is. I can do that. That's fine. Okay, so we'll just keep going. So if it's not a pound sign, if it's not a C, perhaps it is an X. That's the next thing down. Clear the current list of contents. Clear. So we immediately encounter a problem here. And let's see if you can figure out what it is. I have a problem in here. So I'll give you a hint. I have this block of code that declares and creates a dynamic instance of a W-link list. And then I have this block of code that calls clear on that list. So what's the problem? Might not be easy to see, but it's pretty critical. Good one, Tyler. So exactly. This also Robbie, perfect. So I can't access list in this block of code if it was declared in this block of code. So I got to get this declaration out of here. I need to get this declaration out somewhere so that both blocks of code can see it. So I could go up to this block of code. It's still got a problem, and let's see if anyone can figure out what it is. So step one is to get that declaration out of that block so that so if I declare it here, then both of these blocks can see it and they can both operate on it. Still got a problem, so now maybe this one's a little bit harder, but you guys picked off the first one. What's the problem now? As I'm reading through a file and trying to do things, what's the problem now? Harder to find. Good one, Robbie. So outstanding. If I am processing a series of commands with this while loop, and I'm declaring this list in the while loop, every new command that I process from the file is causing a new list to be created, and I don't want that. I want the file to be able to operate on a list for a sequence of commands. So I can't put it here. I got to make sure that I declare the list somewhere, which it's safe to put it up here. I need to make sure that I declare it somewhere so that when I'm operating on it, as I read commands from the file, I'm not accidentally recreating a new one, and then I will never get any good results. So you got to watch out for that kind of thing. Where you declare this totally matters. It's safe to put it in this if, because if I can get the file open, now I'm ready to start doing doubly linked list stuff. And then while I am reading commands from the file, I'm operating on that single list pointer. So outstanding. Okay, so hopefully everyone's seeing where we're going with this. Now that you've seen the flow here, I'm going to go back over to the repository and show you the other part of this. So ignore his comment. So we're going to stop right on this X one, and then we're going to go look at the other challenge here in the repository. So we have the required operations, so we've got all those copied. Now we also have required outputs. So this file is a little bit scarier to read, but it's showing you, like for the C command, the required output is list created. And for X, it is list cleared. Okay, fine. So I can remember those. I'm going to be careful to spell them properly, but so on the C, after I create the list, I'm going to C out list created and a new line character. And for the clear one, cleared. So that's the required outputs to go with those two commands. Now if you wanted to, I'm not going to do it because I think it would take a lot of our time, but hopefully where you saw where I got that, if I go to the repository, for each command there's also a required output that goes with it. So this is the output. I haven't dealt with this. Any operation executed when dynamic list is null, with the exception of C, should say this. I should probably go take care of that right now. So let's go do that. Any operation executed with a null pointer should print this out. So let's go deal with that. Must create list instance. With the exception of C. So here's an example of one that does. So it's telling me I got to be careful of that. So if list is null, otherwise I can actually do the thing. So any operation other than the create operation. So once you get into the X section, if the list is currently null, obviously you can't clear it anyway, but what you're supposed to do is print out a message that says, oh, you got to create one. Let's try those out, shall we? Let me make sure I don't have any potential. I think I can probably get away with running this right now. We will see if my doubly linked list is in a state where I can do that. Hopefully everyone saw where I got the commands from and where I got the outputs from. So there's a series of commands, and for each command there are potentially multiple different outputs based on the command. If you're clever, by the way, you can probably figure out how to do this must create list instance more efficiently than what I'm doing. But I'm going to do it the least efficient way so you can see me walk through the whole thing. Alright, so let's make an inputs file and test this stuff. So I will call this inputs1. Should be able to have comments. I can do a clear. If I do a clear without having created a list, it should say must create list instance. I'm going to just literally try that and nothing else with my little comment. So I'm going to run this program. I'm going to get an error because I didn't provide a file. So you've done this before. I need to give it a file. I'm going to give it a bad file first just to see if it does that right. Great. If I give it a non-existent file, that works great. Now if I give it a real file, it crashes, and why does it crash? X should have found that thing being null. X. I don't know what is happening here. I know what it is. I know what it is. It is this blank line right here. Let's go ahead and handle that, shall we? It's crashing. I noticed that it says down here in the output, this size is 0, and then I thought, well, it doesn't even, I'm pretty sure that my other code's right. It's this empty line. Technically, the project doesn't say I have to deal with that, but I'm going to go ahead and deal with it. Why not? Plus, I can show you how to deal with it. So, and I also want to just show you this trick. So, what you can do in many languages, C++ included, I can test to make sure that I'm not getting a blank line. But if I use the keyword continue here, what this does is it actually bypasses the entire rest of the loop's contents and jumps right to the bottom of the loop and then continues the execution of the loop at the top. So you can use this keyword to continue if you need to, for some reason, bypass some or all of the contents of a loop. So when the line that I just read has nothing in it, I'm going to bypass and just start the loop at the next read. Kind of cool. And it doesn't mess up my, oh yeah, I'm an idiot. Okay, so the continue worked. It didn't try to do anything on an empty line, and I got what I expected, which is must create list instance. So that's a good thing. So now if we go do the inputs again, I will create and then clear again after, and in the meantime I'm going to put some more comments just to make sure they get ignored. I can also put some blank lines because now I have the ability to handle that as well. So I'm just spreading a few comments around just to make sure that those work, and since I wrote code to handle blank lines, I went ahead and allowed myself to use them if I want. Technically, the project doesn't require the blank line handling, but why not? Okay, so I'm going to call clear, and it's going to tell me that I don't have a list to clear. And then I'm going to create the list, which should say list created, and then I'm going to clear the list, which should say list cleared. I don't have to recompile the program because all I did is change the input, so I'm just going to rerun it. Must create on the first X. Notice that the comments and the blank lines aren't breaking anything. There's the list created. There's the list cleared, so that's all seems to be working nicely. Okay, on we go. I'm not going to do all of these. I'm going to sort of get up to the ones that I know are difficult. So delete the dynamic list instance. So let's do that one. I'm going to watch the time a little bit. Okay, I'm doing all right. So I'm just going to keep adding commands here as I go. D. So D is another one of those that should do they must create list instance if required. So if list equals, remember the only exception to this rule is the C command. Every other command, well, the comments, because they don't do anything, but every other command has to do this bit. Else I can delete the list, I can set the list equal to null, and then I can do the required output. Every command has a required output, so for the case of delete, the required output is list deleted. So now I can actually add that to my inputs. I have to recompile because I changed the code. So now I'll go rerun it. So must create, that's the X. Clear, created, cleared, deleted. That's what the output should look like. Hopefully that makes some kind of sense so far. Okay. I forget where I'm at. Oh, back to main. So hopefully everyone gets the idea. You can just work your way down the list here. And whenever you encounter one that you don't have support for, then you need to go implement it, which we're about to do right now. So the I command, which comes with a number with it. We did this in week 11, but I'll do it again. So when I get an I, this is one of those where I need to check because the only exception is C, create. Uh-oh. I don't know what I touched, but hopefully, oh, okay, it's okay. That's another one of these. Else, it's safe to do the stuff. Okay, so every command should attach itself to one of your doubly linked list functions. So what I want to be able to do is call a function, let's say list insert here. Oh wait, I gotta get the data off, don't I? So the data equals string to integer, and then I'm going to take the line. We did this in week 11 if you don't remember. Move 2 characters over, which gets me the number. Not like that though. So I'm not going back over this because I did it in week 11. That's moving past the character, that's the command, past the space after the command, that's the 2. So what this grabs is everything else on that line, which for the insert command should be the number, and then I convert it to an integer. So now I have data, and what I want to do is call insert that data on the list. So the problem here is that I don't have a function to insert. If I look through here, I have a constructor, I have push front, but I haven't done that command yet. I have push back, I haven't done that command yet. I have pop front, I haven't seen that command yet. Pop back, I haven't seen that command yet. Front, nope. Back, nope. Get size, nope. Empty, nope. Clear, used that one. So if I scroll down through my doubly linked list, what I notice is I don't have an insert function. Well, that means I'm going to have to make one. So let's make one. Remember, we're in a template. So when we're working in the doubly linked list, we know it's integers in our mind, but the doubly linked list doesn't know it as an integer, it knows it as a T. That's the template stuff. Okay, insert is challenging, so I'm going to have to draw pictures of this, but I just wanted to point out to you, that as you are developing your driver, the idea is that as you work your way down the commands, each of these commands should map to something in your list. So each of these commands, you do some function on your list after checking it for null. So this F is push front. The B is push back. The E is eliminate. We don't have that yet. The R is remove. We don't have that yet. The G is get. We don't have that yet. A we have, that's front. Z we have is back. T is pop front. K is pop back. N is get size. And P we need to use print. So there's a lot of commands here, but the idea is that for each of these commands there should be something in your list that does this thing. So we're going to work on insert together because that's a hard one on a doubly linked list. So this is going to take a few moments, but hopefully you see how I arrived there. What's the output say for this, by the way? The output for insert is value n inserted. Okay, so I'm going to go ahead and do that, even though I haven't done it yet. See out. So value, got that data, inserted. I was careful to put spaces around it so that the output is correct. Okay, so now let's go work on insert, which is a hard one. So hopefully this is not too fast, but again, you'll have it on video so you can stop, rewind, pause, and whatnot. Okay, so in the case of insert, I'm just going to go work on that right now, but hopefully you get the idea that as you work your way down, your job is going to be that you need to make sure that you have an implementation for these things and that they work. So inserting on a list. Let me switch views. Hopefully the camera's working. I don't know why that's... Yay. Okay. So doubly linked list. Let's set up some scenarios here. Head, tail. I'm just going to use H and T. Null. So one scenario is that we're trying to insert a value on a doubly linked list that's empty. We want to consider the possibility that inserting one on a list that only has one thing in it might be weird. And then what would it mean to insert one on a list that has more than one node in it? Because the hard part is inserting one in there between two other nodes. That's the hard one. So let me just show you the part of the trick of solving this problem is to use your other functions to reduce your problem space. And let me show you what I mean by that. Okay, so what does insert mean? Insert means that if I have a list that has 10 and 20, and they call insert 15, then I want 15 to go in between them. So the insert command means take this data and put it in here in the proper location. We'll talk about front and back here in a second, but for now, just worry about insert. If you get inputs in your file that have insert, then that's the whole sequence is going to be insert. So insert means take a value and put it in the proper ascending order location in the list. So an insert 15, if I did an insert 21, that should go at the end. If I did an insert 5, that should go at the front. So this is the hard one. That 15 is the hard one that goes in between two. The ones on the ends are actually easy, as is the empty list one. So let's go do start implementing that before we deal with this nasty one. camera off, Firefox on. So I'm doing my insert function in my doubly linked list. So the thing to do is to make other functions do work. So we can offload most of the insert problem simply by using other functions to do stuff. So if, for example, the list is empty when a value comes in, then why don't we just push front? And we're done. Let push front do it. It knows how to take a value and put it in an empty list, so just let it do it. So if you try to insert a value on an empty list, then I'll just use my own push front function that already handles that problem. Another situation, if the value is less than or equal to the heads value, I'll let you answer that. If the value I'm trying to insert comes before the value at head, so I just compare them, what should I do? Can you see? Yeah. If I screw up the view, please let me know. Push front. Good one, Robbie. Yeah. So if the value I'm trying to add is the same as or should come before the value at the head, I'll just use push front to do that. What about tail? So you have to be somewhat familiar with the doubly linked list now. I will give you a hint from last week. Push back. Good one, Tyler. So push back. So I've already handled all of the straightforward situations. Empty list, just push front. Takes care of it. Should be at the front of the list, push front. Should be at the back of the list, push back. And I do that simply by taking the value and comparing it with the values at either end. Because this is written as an if-else if, it won't break, right? So if it finds the list is empty, it will push front and it's done. But if it's not empty, then it will look to see if this value should come before the value in head. If it should, it pushes it front. If that's not the case, then it'll see if it can put it at the tail. So the only other situation that it could possibly be left is that it has to go in between stuff. That's the only situation that it can possibly be, is it has to go in between stuff. And that's the hard one, and we're going to work on that together. Firefox off, dog camera on. So let's see if I can draw this a little more spaciously. So the only situation that we have not, I don't know why I drew that over there. The only situation that we have not dealt with is an in-between situation. I'm going to sort of vaguely draw these lines. So let's say that we have 10, we have 20, and we want to insert 15. So we've already got an algorithm. If it's 10 or below, it's going to get pushed here. If it's 20 or above, it's going to get pushed here. But this is the situation we haven't dealt with yet. What if it goes in between stuff? So if it goes in between stuff, which means that we know, the only thing we actually know now is it doesn't go at the front or it doesn't go in the back, but this is the only other possibility, then we're going to have to write an algorithm that finds the spot where it goes. There's a whole bunch of different ways to do this, but our problem is we're going to have to start at the head and we're going to have to iterate the list until we find the spot that this goes either after or in front of. I'm going to do in front of. So we're going to make the temp pointer starting at head. And we're going to say while my value, which is 15 in this case, is greater than, I'm just going to say greater than, so while my value is greater than temp's value, I'm just going to move temp over. That's a lot of the algorithm. So while my value, 15, is greater than temp, I'm going to move temp over. So in this scenario, my value, 15, is greater than the value at temp, so I'm going to move temp over to next. At which point, my value is no longer greater than this value. So when this loop is done, I have temp pointing at a node where my value needs to go in front of it. In front of it. So I need my value to go in front of here. So I'm going to make a node for this, 15. And I just want to point out to you how many pointers there are that we have to mess with. So we got to get these two connected. And we have to move these two. So we have 4 connections we have to make. 1, 2, 3, and 4. 4 connections we got to make. So this will be my node star n equals new node with my value. Hopefully you can see that. So here's n. And then we got to do a whole bunch of messy connections. It's not nearly as bad as it looks. So connection number 1, this one right here. I wish I had a better. I wish I had both the code and the drawing going, but it's fine. Okay, so n. You have to be familiar with the doubly linked list node to know this, but does anyone remember what the name of this pointer is that I put right here? That's n's prev, good one. And I want to point it at this node right here, so I can actually get to this node through temp. Sorry about the messy picture, but I'll go improve upon it on the next page. So n's next should point here, which is the same as temp, or n's previous is should point at the same thing that temp's what points to. So n previous needs to be the same as temp's previous. Good one. Temp's previous. So now n's previous matches temp's previous, so they're both presently pointing at the same thing. That's connection number 1. I know what I can do. Get myself a piece of paper and then cover this spot. Okay, so that's connection number 1. Is that stuff. Actually, this is all we really need at this point. So connection number 1, ends, that's the new node, previous is the same as temp's previous. All right, connection number 2 is ends next, good one, is the same as so ends next is going to point to the same place as not temp next. So temp next is this one. So we don't want temp's next. We don't want temp's previous. we want temp. Good one, baby doll. So you guys are doing good. This is hard. We want ends next to point to the same place where temp is currently pointing at. So now we have the new node all hooked up. Now we got to move 3 and 4 around. Okay, so 3 is dang hard to do, so let's do 4 first. 3 is intimidating. We're going to do it, but let's do 4 because that one's pretty easy. So 4 is temp's previous. So we want to take this one and point it here. So temp's previous should point where? This one right here needs to point in. Good one. So I take temp's previous and I point it at in. So now those are connected up. So this last one is a nasty one. So I need to get this node's next. Which is the hardest one to get because we don't have any pointers pointing at it right now. We don't even know if it's the head node. So for starters, let's just say where do we want this one to point? So this one that presently points all the way over here needs to point instead to here. So somebody's next needs to point at N. Because we want this. The question is, how the heck do I get to this? It's a tricky one. So the hint is, and then I'll let you work it out after that. To get to this node, I have to start here. So to get to this 10 node, I have to start with N to get to it. So good one, Damien. So N previous gets me to this node, and then I just chain it into next. So I go N to previous to next, and then I move it to point at N. Isn't that crazy? That's the hard one. So I go N to its previous, and then take that next and point it back at N. And then it's all in there. Pretty wild. So anyway, notice how I chained those pointers together to get, I started at N, took its previous, and then took its next and moved it. Deleting is harder. Yeah, a little paper points out, this seems like, now number 3 was the hardest one, and insert is hard, but well, delete's similar, but potentially easier to make a mistake. So let's go implement that stuff real quick. How am I doing on time? I'm doing all right. So let's go implement that. Okay, so we need a node. Then we need a, here comes our loop. So we make the node to hold the value. We could have put that off, but I went ahead and did it first. Here's our temp. And all we do is we use temp to figure out who do we go in front of, right? Once we get there, then we say, what were the things? So we say ends previous equals temps previous. We have ends next equals temp. We have ends previous's next equals n, and we have temps previous equals n. We can then increment the size of the list by 1 because we just added a new node. So that one is quite hard, which is why we sort of did a walkthrough of it together. That one's tough. But with that, we actually have the ability to do the insert now in our driver. So that one is difficult. But now we have the ability to do an insert. So in our inputs, I'm going to get rid of these comments. Am I? Yeah, for now I am. And let's see, I'm gonna, well, insert should trigger, that should trigger a must create list instance also. So I'm gonna create it and then I'm gonna insert some stuff in a weird order, right? So I'll insert a 20 and then I'll insert a 10 and then I'll insert a 15. Now I can't actually see if it's working in terms of the data, but one thing to note here is that once a list has been created, then if you start using the insert function, that's the only way that you should add data to that particular list is with insert function. So I'm not going to mix push front or push back on a list unless I've cleared it and I've reset and I'm doing it with push front and push back. So insert is meant to be its own kind of list. So you create a list, you only ever use insert on that list, and you don't mix that with any of the push stuff. I did change the code, so I'm going to rebuild it and then rerun it. So I can't see yet if those have been inserted, but it didn't crash, and the outputs look like what they're supposed to look like. Okay, so let's go back to the driver. This would probably be a good time to go ahead and get the print in there so I can see what it looks like. So let's add print. This is another one of those that needs to check for null before we do anything, per the rules. Otherwise, I can just print it. I think it's to string, yeah. So I believe, let's see what the required outputs say. I suspect that on a print, it should say empty list on an empty list for print. Or it should have the numbers separated by commas, which I think my function already does that, but what my function does not do is say empty list. So I need to be aware of that. Let's go look and see to string if it does the commas thing. It does. So that should be okay. But the empty list is a different output. So here I have to add additional logic. So if the list is empty, then I'm supposed to print out empty list. Otherwise, I'm supposed to show the actual output. So you really have to pay attention to what's going on here. Hopefully everyone saw where I got that from. In the required outputs, it told me either the numbers with commas in between them, which is what my toString already does, or empty list as opposed to nothing. So I had to be aware of that. By the way, notice there's other commands that do that. Empty list, empty list, empty list, empty list. So be aware of that. I'm going to change my inputs, and I'm going to, so right after so this insert shouldn't work. It should say must create list instance. Then I'm going to create one. This is the sorted list section. Uses insert only. So I create one, I print it, it should say empty list. I want to test that. Then I insert a few. Then I'm going to print it, which should show them with the commas this time, and then it will clear it. Then I should be able to print it again, and it say empty list, and then I'll delete it. So hopefully you guys are seeing how these command files work. They're a way to test. I changed the code, so I need to recompile. They're a way to test. Alright, so must create, let's create the empty list. Perfect. Insert, insert, insert. They print out in the right order with commas. It clears. Then when I try to print it another time, it says empty list because now the list has been cleared of its contents, and finally it's deleted. So what I've done here is I've created my own set of inputs. So now if I go grab okay, so there's a sample input file here. It has a whole bunch of stuff in it. So I'm going to go add that, and I'm going to experiment with it in my program. And then I want you to see this is a very important part for confirming that your own code's working correctly. So I'm actually going to add another inputs file. Call this one sample inputs. And I'm going to run my program with that file and see what happens. I'm worried it's going to crash, but who knows? So hopefully you notice here the idea is, and this is what we'll do when we evaluate your code, we have multiple input files that we've created, and we're going to try some of them out to see how your program handles them. So instead of my inputs 1, I'm going to try the sample inputs, and I get these outputs. So I want to show you this is super important thing for testing your program. So it also tells me here that this is the outputs that file should have done. Now I am positive that my program did not do these outputs. There's no question about it, right? But I want to show you how you can confirm this and show you how we're going to confirm it. So I have the sample inputs. I ran my program against the sample inputs, and I got these outputs. Now, the repository says that these were the outputs that I should have seen on those inputs. So super important thing that we're about to do. How can I tell for absolutely sure that mine are either the same or different from these? Go to Google and type online diff. So this is a cool thing to know how to do. Online diff. I'm just going to use the first one that I come to, diff checker. What diff checkers do is, go away, they allow you to compare two files. So the way that you test, the way that you confirm that your program is actually working on this project is you take the expected outputs, you paste those into one side, and then you take your outputs, you paste them into the other side, and then you click on the find the difference. And if you're getting red, then you've got giant differences. Of course, I don't have any of these functions implemented, so I'm missing all of that stuff. Although notice the first two match, and then there's a few others that seem to match. So online diff, this is the way that you can take your outputs and confirm that they match the expected outputs. Online diff. I use diff checker, it doesn't really matter. So the reason why the sample is here is that when you run your program against the sample input, it's expected that your program will match the sample output. And that's one of the ways for you to confirm that your code's working is you take your output and you use an online diff checker to compare it with the sample output and try to get them to match. That's not the end of the story really, but that's a good starting place. So we have multiple input files, just so you know. We're going to try multiple input files, and we have our own outputs from those inputs, and your output should match our outputs if your code is correctly implemented. So you probably want to do some testing with your own inputs, like I've been doing here with inputs 1, and sort of check the outputs to see if they match. Now we have some input files that have hundreds of commands in them, which kind of stress test your code, but if you are doing okay with the sample inputs, then probably you're okay, but you should also try some of your own. Okay, so time, how are we on time? We're doing okay on time. Well, we're not doing great on time. I'm going long. So I want to do delete, and then I want to switch over and just give you some introductory comments about this week's lab. For some reason I'm having I'm having a network issue. Did we lose the internet? No. Okay, thank you, little peeper. Just something felt wrong there for a second, and my REPL wasn't connecting, and then I got a reset on the chat room, so I didn't know what was going on. Okay, let's do delete together, and then I'll give you a couple of introductory comments about recursive thinking, but I've got lots of content in that in the supplemental videos. So I figure that for you guys, the priority is knocking out a good result on the project, so that's what we're focusing on. Okay, where were we? Oh, we need to do delete, don't we? Okay. So I went ahead and added print, so delete. Let's see. So these two, eliminate and remove. So the difference between eliminate and remove, the way our list is written, you can, and in fact I'll just do it, you can insert the same value more than once. Which is fine, and it's, you can't do that. Can I clear? Yeah. So you can insert duplicates. So the job of the remove function is to remove the first instance that it encounters. So we're going to do remove a number, and then we're going to do eliminate a number. So remove simply says that else. Get rid of the first one that you see. So next line dot at 0 equals R. We need to check for null. Print out on that instance. Otherwise, we can do a remove. Now let's go look at the expected outputs for remove. R. Okay, so the expected outputs are we either succeed in removing it or we fail to remove it. So we need to be mindful of that when we implement this function, that we need some way to signal a success or a failure. Okay, so list is empty. All right, so the next thing is we need to get the data off, so I'm just going to go grab my code that did that. And then we want to do a list remove that data, and its job is just to get rid of the first one. So we don't have that function because it has to seek the value and then get rid of it. So let's go implement that. I will do it maybe after the pops. Okay, so this is a function design question. If I have a function, so for example, if the list is empty right now, I'm not going to be able to remove this value because it's not even there. So how do I signal to the caller of this function that I failed to remove your value? If I have an empty list, I can't remove your value. I'm going to fail. What's a way to signal that failure to the calling code? That's a hard question. But how do I, from a function, return the information that, uh-oh, I failed? The hint is, okay, good, Tyler. So I need to return something, right? So instead of void, I need to return something that says success or failure. What's a good return type for bool? Good one, Robbie. So if I make this a bool returning function, then I can use false for failures. So if the list is empty, well, clearly I'm going to fail to remove the thing, so I'll return false. And then I'm going to do the same thing that I did with insert. If the value I'm trying to remove matches the value at the head, I'm going to pop front, and I'm going to return true because I got it. Easy enough. I'm also going to check the back. I'll pop back and return true because I got it. So I can make my job a lot easier if I get rid of the ends, right? So I just sort of look directly at the head and see if it matches the value that I'm targeting. If it does, then I do a pop front to get rid of it, and then I return true. Otherwise, I do a pop back to get rid of it and return true. So the only other case for remove is the same situation that we had with insert. We're going to have to find the matching data. So I need a temp. I'm going to start it at head. Now this one's a little bit different because I can't assume that I'm even going to find the value. So you have to assume that you may actually fail to find the value. And the way that would work is while temp is not null, if temp manages to walk off to null, then we failed to find the value. So while temp is not null and the value does not match the value that I'm pointing at, then I'm just going to walk temp over. I didn't draw a picture of this, but I'm checking two things as I iterate across the list. One thing I'm being careful of is I want to make sure that I detect the situation where I fall off the end of the list. And that would happen, sorry, there's a tickle on my nose. That would happen if I never find a matching value. So as long as I haven't walked off the end of the list and I haven't found a node containing my value, then I'm going to walk this pointer over. Now eventually that's either going to fall off and become null, or it's going to land on a match. So once I've done this loop, temp is either null, which means that I walked through the entire list and I never found a matching value, which means that I can't remove your data, or I'm pointing at your data. I might need to draw a picture for this for us. So let me switch views. Dang, I'm going longer than I thought, but hopefully this helps. Okay, so we already did the empty list situation. We already did removing the ends. So the situation that we have now can only look like this. So we already did the check for an empty list, handled it. We already checked to see if what we're trying to remove is on one of the ends, handled it. So the only other situation we can possibly have is that we're between stuff. Which means that temp is going to land right there. Okay, so now we need to look at all of these links. The links for temp itself, we can ignore because when we delete temp, those links are going to go with it. So the links that we have to worry about are this one and this one. So we need to reroute this link around temp, and we need to reroute this link around temp. So this is one of those nasty ones because the only way we're going to get here is through temp. So how do we get here from temp? So we started temp, and then how do we get to this one? Previous, good one. So we started temp, we go over to the previous node, and then we want to change that one's next node. So we want to temp to previous to next, that's this one, and we want to point it over here. So over here is also anchored to temp. So temp's previous's next points at temp's next. Good one. All right, you guys are rocking it. So that's the first one. Reroutes this link all the way around. Number 2, I hope I left room for it. So now we got to get this one. So we'll go temp to So now we're going to go temp to next to I blocked to this one. So temp to next to previous, and we're going to move it to temps previous. Crazy. So that's a lot of chain. But if we do that, we've rerouted these two, at which point we can delete temp and it and its own links are gone. So that's two, yeah, indeed, it is like musical chairs. That's pretty hairy to work that out. So let's go implement it. Okay, so otherwise, we need to say temp previous next is going to move over to temps next. So we reroute it completely around temp. And then we take temps next's previous. So this kind of feels like you're doing this. Is rerouted around temp to temps previous. And then we can delete temp. That's all you need to do here is just delete temp, and that node and its links and the data in it are gone. We need to, at this point, reduce the size of the list because we actually did delete something. And then we can return true because, hooray, we were successful. So that one's pretty nasty. So that's remove. I can't actually test this because I don't have pop front. I don't think I have pop back working on mine. So you'll need to test this, but hopefully you kind of got the walkthrough. So that's remove. So remove is going to return a Boolean. Which means that you need to check, right? So the output for that is value n removed or value n not found. Okay, so this would be cout value space data removed. Notice, by the way, we're putting the actual data, not the character n, so value 8 removed. Else value the data not found. So that's the remove code. It's getting to be a lot of stuff, but let's do one more and then I think I can shut up about these things. The other one is eliminate. So notice, by the way, that we just found the first match and we removed it. If there was more than one match for the value, we don't care. Now for eliminate, we do care. So still need to check. This stuff. Okay, so get the data. And then I bet that eliminate. Yep, so notice eliminate is very similar, except for eliminate's job is to remove all of the matches. Now this one's very, very, very easy to implement. But eliminate is remove all of the matches, even if there's more than one. Remove, all it does is removes the first match. So eliminated as opposed to. So we can basically copy all this stuff. We're going to say list eliminate that data, and then the output, if we get a true back, will be eliminated, otherwise not found. We're going to go to eliminate so I can show you how that works. But it's going to be similar, except for we don't have to implement the whole thing this time. So eliminate some data. So I'm going to have that function return a bool that tells me that it found and was able to remove at least something. Okay, so here we go. Let's do eliminate. So the trick here is to not reinvent the wheel. We already have a remove function that does this. We just need to keep removing until we can't find the value anymore. So while remove value keeps returning true, just do it. Just keep calling it. So I can actually just, as long as I call it, I get true, I try again. Call it, get true, try again. Call it, get true, I try again. Hopefully that makes sense to everybody. Now the trick is, how do I know that this happened at least one time? How do I know if this triggered at least one time? Because as it is, I don't really have any means of detecting. If I say return true here, the first one it removes, it's done. That return short circuits the whole function. So I can't do that. I have to let this loop finish before I can return a result. So the way I would do it is I would simply just count. Just count how many I remove. And then if I remove more than 0, then I succeeded. That's how I would do it. Just count. How many do I remove? If it's more than 0, then it was a successful run of the function. Is how I would do it. So you don't really have to do much work there. You just have to be clever about detecting whether or not you succeeded in even removing anything. So that's the point here is if I can't find the value ever, then removed is going to stay 0, and this will return false, meaning I couldn't eliminate it because it wasn't even there. That's right. Yeah, that's right, Little Peeper. You're exactly right. Removed would be 0 if the value to be removed wasn't even there once. So it doesn't really matter if it's there 10 times. If it's there 1 or more, then I will say, yes, I succeeded. I eliminated something. I think that's... Let's go look at the driver real quick. Make sure I'm not leaving any bad ones off. Get could be challenging. I'll do the get. I'm not going to do the command part of it, but I will show you the get. What's its job? Let's see what the outputs say. Found or not found. So get doesn't remove anything. It just says basically, can I find it? So bool get a value. I would do it this way. So start at the head. While temp is not equal to null pointer. If I find a match, then I return true. And I'm rushing it a little bit. So I start a pointer at head. As long as that's not null, so if the list is empty, this will never happen. But if the list is non-empty, oops, else. Move the pointer over. So I'm going to iterate the list here. If I can find a matching value, then I will immediately return true and the function's over. Otherwise, as long as I'm still not finding a match, I'll just move temp over 1. And keep doing that until I either find a match or I run off the end. So in the case of this function, if I manage to get down here to line 127, the only way that would happen is if temp became null. And the only way that would happen is if I don't have that value in my list or the list is empty. Either way, I can't get it. I can't get it from an empty list, and I can't get it if it's not in the list, so I'll return false. So that's all I'm going to show you for the get. You're going to have to be clever about setting up the command part and check the result to see if get got it. So this is really, is it there? Can I get it? True or false? Can I find it? Pretty sure that that's what that one's supposed to do. Yeah, so you can either find it or you can't find it with get. List, okay, that's front, back, pop front, pop back. Notice you got to check for empties on these. Get size, we did print. That should be all of them. So, whew, that's probably as much as you guys care to take from me right now. So there is a lab. I will tell you that, can you see? You can. So I believe it's the second supplemental video of the 2 has a complete walkthrough of the lab. So instead of making you sit here for 2 hours in one spell, there is, the supplemental videos have a walkthrough of this week's lab, so that's what I would have done if I sat here for another hour anyway, is that same thing. So the complete solution for Lab 13 is in the supplemental videos on the lecture page this week. And then I'll return to these thoughts and we'll look at additional applications of it. But also your Zybooks reading should have something about recursion also. So thanks for sitting through all that. I decided I should prioritize your project work because that's the big chunk of points. The supplemental videos have a complete, I believe, solution to the lab, so that's already there. So you can use it for guidance. And otherwise, I think I'm going to stop. My voice is starting to conk out, and you've been here for an hour and a half. So thank you. I appreciate it, baby doll. Thank you for everyone participating. Hopefully that's super duper useful for the project. I mean, I think that hopefully you're in a position where you can knock it out. Appreciate it, Tyler. So please take advantage of Piazza. If you have questions about the lab or the project. Have a good night. Have a good rest of your week. So remember, next week is Thanksgiving week, but Butte College does classes. So I will be back here on Tuesday next week. We will review the basics of recursive algorithms, and then we'll start using recursive algorithms to do another data structure. So good luck on the project. I hope that I have armed you with what you need to be super successful on it. Okay, yeah, so I'll close with the thank you, Robbie. Appreciate it. Happy Thanksgiving to you as well. So Little Peeper asked how, when will I get the video posted? So the video is immediately available on Twitch. As soon as I shut down the stream, you can see it on Twitch. I then export it to YouTube, which usually takes about a half hour or so to complete. And then on the lecture page itself, that usually takes the whole process about 2 hours to get it uploaded into that system. So it's usually about 2 hours from now where the whole process is completed. But this video is immediately available on Twitch as soon as I stop the stream. So that's right, yeah. So I stop, it's immediately available on Twitch. I export to YouTube, which takes somewhere about a half hour. And then I also then upload it to the captioning service, and that process takes about 2 hours for me to finish that. So about 2 hours from now, everything from right now, the supplemental videos are already available. Okay, appreciate it, Little Peeper. Have a good night, everybody. Have a great week, and I will see you again on Tuesday. Use Piazza. You've got good helpers for questions for code. So take advantage of Piazza and do great on the project. It makes me happy to see everybody do great, and I'm sure it'll make you happy and confident if you do great. So do great and have a good week. See you next week.